Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. Today we are talking about the key terms in scheduling. So, we have already talked about basic terms like flow shop, flexible flow shop, job shop, flexible job shop, and other foundational concepts like what is a job, what is a machine in a manufacturing setting. So, now continuing from those discussions, the next term is preemption. So, sometimes what happens is it is sometimes not necessary to complete an already started process. On the machine for jth job, right? So, let us say you have started machining on a particular lathe machine and you do not require the complete processing of that individual process of machining, right. So, what happens is you can remove your workpiece or your job from the lathe machine and then you can schedule another job. So, usually it is required when you have different kinds of job with different kind of processing time, and this provides you some kind of flexibility, right. So, it is assumed that the amount of processing on the job is not lost, and when job gets back on the machine, it continues to only complete the remaining process. So, it will now when it comes back to the machine, it will not take the complete processing time that is required for that particular process on the lathe machine or whatever machine we are utilizing, right. So, it will only take the remaining processing time that is required to complete that particular job. The next thing is precedence constraints. Precedence constraints. So, this can appear in a single or parallel machine environment. It defines required sequence of operations for a particular job. So, what happens is, let us say for a particular job you need to perform drilling, milling, machining, tapering. Now, if this job has already stated that out of these 4 operations, the first will be drilling, then tapering, then let us say milling, and finally machining. these are the sequence of operations that needs to be performed, and it is not possible for this job to first do milling and then drilling. So, these are the different kinds of precedence constraint, that is what precedes with what, right. So, these sequences will rule out many schedules that do not follow these precedence. Okay. So, let us say without any of these precedence constraints, you need to schedule this job with these many particular operations on a machine. Okay. So, you can get multiple schedules that are possible to, let us say, for an objective to minimize the make span. But what happens is, once these kind of precedence constraints comes into the picture, your scheduling operations will have less number of possible and viable schedules that you can create on a particular machine, right. So, these precedence constraints will make your problem more hard of scheduling jobs on a particular machine, right. So, let us now talk about what are the different kinds of objectives in scheduling. So, the first is minimize make span. This is also known as completion time. Okay. So, make span is the total time to finish all jobs. So, why we are minimizing this make span? Let us say we minimized all the total time to finish all the jobs in a particular manufacturing environment, then we can utilize that saved time to perform other operations on those machines and can increase our efficiency of the manufacturing factory, right. Another objective could be minimize lateness or tardiness. So, this is the amount of time that the jobs get delayed. Okay. So, if you are exceeding your due dates for a particular job, let us say you need to provide a completed job in mid of the October, but you have already exceeded that by 15 days and it is currently the end of the October. So, your lateness or tardiness is of 15 days, right. So, you have to reduce these 15 days. This is the objective in some kind of scheduling problems. Another thing is minimize flow time. So, this is the average completion time. Next is you can maximize the machine use. So, this is the percentage of time when machines are busy performing some kind of task. You can also utilize objectives like minimize work in process inventory. So, we have already seen this work in process inventory in these kind of systems. Let us say we were talking about queues that are developing because of some kind of bottleneck. So, these queues between machine M1 and M2 will create work in process inventory that you need to manage while performing all these operations in this particular environment, right. So, we need to minimize these WIP inventories. Okay. So, now let us talk about sequencing. So, it is the process of prioritizing jobs and developing process order. So, in which particular order all of these jobs get processed on a particular machine. So, there are different kinds of sequencing. So, types of sequencing. The first could be first come, first served. Here we process the jobs in the order they arrive. Other is the last come, first served. This could be, let's say, if jobs are stacked on a machine, then it gets easier to process the most recently arrived job. Okay. Other sequencing could be earliest due date, where we will process the jobs that have earliest due dates will get processed at priority. Now, another could be minimum slack time. So, what is this slack time? This is the minimum quantity of work required to be performed and time remaining until the due date. So, jobs with least amount of slack gets processed first. Another approach of sequencing could be critical ratio. So, smallest critical ratio. So, what is critical ratio? This is the amount of time remaining divided by amount of work remaining. Okay. So, there are three different kinds of possibilities. You can write CR. So this critical ratio could be less than 1, right? And it, what does it mean is your work remaining is greater than your time remaining. That means you have less time but more work to do, so you are behind schedule. Another possibility could be CR is equal to 1. Your time remaining and your work remaining is same, right? So you are on time. The last is CR greater than 1. That means your time remaining is higher but your work remaining is lower, right? So you are actually ahead of schedule. You have completed most of the work and you have ample amount of time remaining in this condition, right? Another possibility of sequencing could be shortest processing time. Also known as SVT. So here jobs with shortest processing time gets processed first. Okay. Another alternative could be longest processing time. Here jobs with LPT gets processed first. Now let us utilize this new information to perform some kind of sequencing in a particular task, right? So let us look at one of the example. So let's say you have 5 jobs and they have deterministic processing times. So what does this word deterministic means is that the processing time for conducting a particular task on a particular machine is not random. There is no randomness in that operation, right? And in this example we are following first come first serve. So FCFS gets followed. While continuing this example, we will also check with earliest due date. For the same example, we will check this one as well, earliest due date sequencing model and shortest processing time model. Okay, so let us talk about this example. So we have 5 jobs, right? Let's say there are jobs as A, B, C, D and E. Okay, and they have different processing times. So processing times could be for A, let's say it is 5 units, B has 10 units, C has 2 units, D has 8 and E has 6. And we also have the information regarding the due dates for these 5 jobs. So the due dates for first eighth job is 10 unit, second is 15, then 5, 12 and 8. So now let us utilize a table and we will write our sequence, then our start time, then our processing time, then completion or due dates, and finally tardiness. Okay. So we know that we have these 5 jobs, and we are trying to utilize the first come first serve basis. On the first come first serve basis, so let's say our sequence is A, B, C, D and E. So this is the sequence we will utilize. Now at the start the time is 0, okay, and the processing time of A is 5 units. So it will complete in 5 units, and the due date for this is 10. For this B is 15, then 5, 12 and 8. Okay. Now for this BS job, the processing time is 10 units, and we have to start this job only after completing the AH job, which will complete at 5 units of time. So the start time is 5. Now we will add 10 units more, so the completion for the BS job is 15 units, right? The processing time of C is 2 units, and it will start at 15, so it will complete at 17 units. Then the processing time for D, job D is, this is due date, is 8 units. So it will start at 17, it will end at 25. And for ES job, the processing time is 6 units, so it will start at 25 and it will complete at 31. Okay, now we have our due dates with us. So the tardiness is the lateness, or the tardiness is the time that your job gets delayed. So the due date for the first AS job is 10, let's say 10 days, but you have completed in 5 days itself. So the tardiness is 0 here. Similarly, for the BS job, the completion is in 15 and your due date is also 15. So you start counting your due dates from the 0th start point, right? So here the tardiness is still 0, but now the due date for the CS job is 5. That means when you are starting these operations, you need to complete the CS job by 5 days, but when you are completing it, actually completing it in 17 days. So your tardiness is 12. Okay. Similarly, the tardiness for DS job is 13, and for ES job it is 23, right? Now what you can do here is you can take an average of the completion times. So the total is 93, and 93 divided by 5 will be 18.60. The total of tardiness is 48 days, and the average is 48 by 5, which is 9.6. Okay. So this is your first come first serve schedule. Now let us try to create a schedule by utilizing earliest due date. So again we will create our due date sequence, then start time, processing time, completion time, For the due date example, let us write again our jobs and their processing times. So we have jobs A, B, C, D and E, and its processing time as 5, 10, 2, 8, 6, and its due date as 10, 15, 5, 12, and 8. So, to sequence utilizing the due date example, what happens is we need to sort based on the earliest due date, right. So, we will sort these jobs based on the numbers in your due dates. So, this is due dates. So, the earliest due date is for your job C, then it is for E, then for A, right. So, in this fashion we will write the first job in the sequence will be C, then E, then A, then D, and then finally B, which is required in 15 days, right. Now, start time will start from 0 and we know the processing times. So, it is 2, 6, 5, 8 and 10. Our completion time for the CH job is in 2 units of time. The start time for the EH job will be 2, so it will become 8. Then the start time for AH job is 8, then completion is in 13, then this is 13, this is 21, this is 21, this is 31, right. And we know the due dates, like this is 5, 8, 10, 12, 15. So, what is the tardiness here? That means how much late we are in this sequence of due dates, earliest due dates. So, we actually require this in 5 days, but we are completing it in 2 days. So, we have 0 lateness here. Again same requirement. So, again we are in 0 late. Now, the 8th job needs to be completed in 10 days, but it is actually completing in 13 days in this schedule. So, we have 3 units of lateness, then it is 9 and finally it is 16. So, again let us get the average of the completion times. So, to do that, the total of completion time is 75 and average is 75 by 5, which is 15. Finally, the average tardiness is total is 28 and average tardiness is 28 by 5, which is 5.6. So, we have actually reduced our tardiness from the earlier example of 9.6, right. So, this was the tardiness, that means the average delay in this sequence FCFS sequence. Our average lateness was 9.6, but in earliest due date it is reduced to 5.6, right. Now, let us again talk about the different sequencing order, that is the shortest processing time. So, now let us follow SPT, right. So, we will write our jobs again B, C, D and E. The processing times are 5, 10, 2, 8 and 6. The due dates are 10, 15, 5, 12 and 8. Okay. Now, to accomplish the sequencing by utilizing shortest processing time, we will sort all of these jobs based on their least sequencing time. So, we will again create our table. So the least processing time is of CS job, right? So we will start our sequence with C, then it is A with 5 units, then it is E, then D, and finally B. Okay. So let us write the processing time here as 2, 5, 6, 8, and 10, and our due dates as 5, 10, 8, 12, and 15. So the start time will again start from 0, and the completion for the CH job is 2. Okay. Then A will start at 2 units of time and it will complete at 7 units. Then E will complete at 7 units, and E will start at 7 units and will complete at 13 units. Then D will start at 13 units and will get completed at 21, and B will start at 21 and will get completed at 31. Now the tardiness for the first job is 0, again the second job is also 0, for the third job it is 5, because our due date was 8 units and we are completing 5 days late at 13 days, right. Similarly this is 9 and this is 16. So the average completion time is, total is 74, and average of the completion time is 74 by 5 is equal to 14.80, and here the total is 30, average is 30 divided by 5, which is 6. So if we compare the completion time, it is only 14.8 units here instead of 15 in our due date example and 18 in our first come first serve example, right. And we have continuously reducing the average tardiness levels as well. So initially it was 9.6, then it was 5.6 in this due date, earliest due date sequence, and finally in SPT it is around 6 units, a minor increase, right. So based on these three comparison, we can write that SPT will always minimize the mean job completion times, right. So we have seen here that the final average completion time of all the jobs in SPT was minimum. The due date sequence will minimize mean tardiness. But no other definitive statements can be given for other rules. So you can mathematically also look based on the operations involved in SPT and earliest due date sequencing, that you can achieve these kind of outputs in these sequences. But other rules like the longest processing time or other different rules, we cannot exactly say what will happen and how it will get compared to other sequencing rules, because the processing time or the actual due dates will have impact on all of these final outputs of all these sequencing rules. So today we will stop here and we will continue by understanding how we can schedule different kinds of operations for different machines and different jobs manually, and then we will look at different kinds of heuristics like genetic algorithm to get the optimal solutions from a large set of solutions. Thank you.